Hi dears, welcome to my channel. Here we are discussing class 10 first lesson chemical reactions and equation. What is chemical reaction? Reaction in which there are changes happening from reactants to product is called chemical reaction. Chemical reaction undergoes series of changes. When a chemical reaction is happened, what are changes? Do you know? We can see. It involves change in state. The state will be changed. It may involve change in color. Color may be changed. It involves change in temperature. The temperature also may be changed, as well as there may be evolution of gas. These four changes may happen if a chemical reaction is done. Let us consider magnesium. Magnesium in a form of a ribbon. Magnesium ribbon is allowed to burn. What will be the resultant? Magnesium ribbon will burn by absorbing oxygen, and we can see the white fumes, and at the end we will collect the magnesium as ashes in the form of white ashes. What is the chemical reaction involved over there? Let's see. Magnesium plus oxygen gives magnesium oxide. This is the chemical reaction. This is the chemical reaction involved in it. When we are representing a chemical reaction, we have to represent in the form of equation. This is called equation. Magnesium represented as Mg and oxygen as O2, and the resultant will be MgO. Okay. Now, see, we have to notice what all changes has been happened. Magnesium here combines with oxygen to form magnesium oxide, isn't it? Yes. But now, what the thing is, oxygen is a number. How many oxygen atoms are there? 2. But here 1 is there. There is something unbalanced, right? Means the chemical equation which we have written is unbalanced. We have to balance the chemical equation. Let's go. What is the balancing of chemical equation and how they have been done? Here I have written 3 equations. We have to see how we can balance the equations. Okay. Here the first one which I have told you already, that is magnesium plus oxygen gives magnesium oxide. See whether the equation is balanced. How can we see? First thing we have to see this area. This is called LHS. LHS area is reactants. Reactants react to form product, isn't it, dears? The arrow sign shows the reaction, and then we will get the product. Okay, dears? Magnesium is the first reactant, and here oxygen is the second reactant. They react together to form magnesium oxide. See, here oxygen, how many atoms are there? 2. How many atoms is there here oxygen? Only 1. So we can say it is not balanced. If it is balanced, number of atoms in the LHS as well as RHS should be same. Okay, dears? So how can we do it? Can I rub this oxygen too? No. You should not change the formulas. You are not allowed to touch this area because this will be the formula and this atom number. This should not be touched at all. This area you should not touch. If you are touching any of these, the formula itself will be changed and the things will be changed entirely. So the reaction will not be correct. We should not touch this area. So what we have to do is, we can add coefficient in these areas to make the number correct. See, how many atoms are there in oxygen? 2. How many atoms are there in oxygen here? Only 1. So here we have to add one more. How can we add? We have to put 2 over here. Can you see? I am putting 2 here. Can you see, dears? Okay. 2 MgO I have added. So oxygen number 1 into 2 will give you 2 only. So oxygen number is balanced. Here 2 atoms, here also 2 atoms. Is there any change to be made? Now see magnesium. How many magnesiums are there here? 2 atoms. Here how many? Only 1. It has to be balanced. So according to the product, we are changing into reactants. here 2. Again we are adding here 2. See, 2 Mg plus O2 gives 2 MgO. Now you see how many magnesium atoms? 2. How many oxygen atoms? 2. Both are 2 in reactant side. See in product side, how many magnesium? 2. How many oxygen? 2. Now the equation is balanced. Is it clear? Shall we do one more? Okay. Iron reacts with water to give iron oxide. It is not ferric dear. It is iron oxide plus hydrogen gas is evolved. How we can balance the equation? First I am saying iron. Iron 3. It is here only one atom is there. Here 3 atoms are there. Oh, instantly I am putting 3 over here. Yes. So iron here 3, here also 3. It is balanced. But if I am balancing iron, what about the rest dears? Here oxygen 4. How many oxygen atoms are there here? Only 1. Isn't it? Is there any other oxygen anywhere? No. So 4 oxygen atoms are there. So I am putting instantly 4 over here. 4. Fe3O4. Fe3O4 plus H2. Is the equation balanced? Have you seen hydrogen here? No. Hydrogen 4 into 2. We can't touch this area. So we have to multiply the coefficient along with the number of atoms over here. So 4 into 2 gives you 8. How many hydrogen atoms are here? Only 2. So it has to be extended to be 8. How can it be done? We have to multiply again with 4. 4 into 2 is equal to 8. So hydrogen here 4 into 2 is equal to 8. Now we are seeing again Fe3. How many iron atoms are there? 3. Here see 3. Let's balance. How many hydrogen atoms are there here? 4 into 2, 8 hydrogen. Here 4 into 2, 8. How many oxygen? 4 oxygen is here. Here also 4 oxygen atoms. Now I think it is balanced, right? I think now it is clear for you to balance the equation. Shall we do this problem? Okay. Carbon monoxide plus hydrogen gives methanol. Carbon monoxide plus hydrogen gives methanol. See carbon, how many atoms are there? 1. Our reactant and 1 our product. Okay, no problem for carbon now. Oxygen, how many? Only 1 atom is there. Here also 1 atom is there. Now see hydrogen. How many hydrogen atoms are there here? 2. How many are there? 3 plus 1 more. 4. Here 4, here 2. What we have to add? We have to add 2 over where? Here or here? Here in reactant side we have to add 2. So what happens? How many carbon now? 1, 1. Oxygen 1, 1. Hydrogen 2 into 2, 4. Here 3 plus 1, 4. Now the equation is, chemical reaction equation is balanced. This is how we have to balance the equation. Close it now. See, here I have written 3 reactions over here, right? We can see, just like the reaction I am not writing, here I have mentioned something as L, G, then AQ, then sunlight chlorophyll, 340 at the atmos ATM, like that something I have written. What is this? Here, iron, I told you now. Iron, it is in solid form. I have written S and the so as a subscript over here. Means iron was in the solid form. Iron is in the solid form. Then water in the liquid form. Then after reaction, Fe3O4 we are getting in solid form. Iron oxide we are getting in solid form. And hydrogen is obtained as a gas. That's why G. Okay. Here, you are familiar with this reaction from 6th standard itself. Do you remember what it is? Carbon dioxide reacts with along with water in the presence of sunlight and chlorophyll. What will be formed? Carbohydrate will be formed along with oxygen and water. What is this reaction called? This is photosynthesis. You know it? This is photosynthesis. It's a complex reaction from simple substances like carbon dioxide and water. In the presence of sunlight and chlorophyll, we are getting carbohydrate plus oxygen and water. as a byproducts. Here, carbon dioxide, they are taking in the aqueous form, water in the liquid form. What is the meaning of this aqueous? Aqueous means solution in water. They are taking not as a gas, but in the aqueous medium means it will be in the form of solution mixed with water. Okay, dears. Then, in the presence of sunlight and chlorophyll, we are getting C6H12O6. That is also in the aqueous form. Then, along with that, oxygen as well as water. Okay, dears. Then the new one, that is carbon monoxide, reacts with hydrogen to form methanol. Carbon monoxide is a gas which reacts with hydrogen, also gas, to form what, ma? To form methanol. They have mentioned 340 atm means pressure. They are giving the pressure on 340 atmospheric pressure by the time the reaction is occurring. So, in the reaction, when we are seeing a chemical reaction, we can find what the reactants are, in which form the reactants are, and what will be the product, and in which form the products will be. And moreover, what all changes or what all things has been added about the temperature, sunlight, because sunlight gives you heat, right? Temperature, whether we have applied temperature on it, whether we have applied pressure on it, or is there any catalyst which can improve or increase the reaction. All these are mentioned in arrow mark, and the reactants and the products also are also mentioned, whether it is in solution in water, whether it is in solid form or liquid form or gaseous form. Okay, from seeing the reaction, the things are clearly identified by us because by this chemical equation. So chemical equation is very important thing in a chemical reaction. Now we are very clear with chemical equations, right? How we have to balance the chemical equation and what all things has to be written over there and what all things to be added in the arrow marks and all we are clear about it. Now we are moving for the types of chemical reactions. First type is combination. What is the meaning of combination? Combine. Combining two reactants or two or more reactants will combine to form a product or two products, and how it will be combining, all this we will see in this reaction. See, first reaction is calcium oxide. What is it called? Quicklime. Quicklime reacts with water to form calcium hydroxide, CaOH twice, that is calcium hydroxide. It is also called slaked lime. Along with that, heat is evolved. It's very important, dears, because you may be having confusion for what is quicklime, what is slaked lime. There is one more lime, that is limestone. What all these, what is the formula of the quicklime? What is the formula of slaked lime? How can we obtain from quicklime? Like that, the questions may be asked. So you should be thorough with it. Calcium oxide is a quicklime. It is in the solid form. When we are mixing with water, what happens? It will become calcium hydroxide, CaOH twice. When we are mixing, along with that, some heat is evolved. How will you understand whether heat is evolved or not? When the reaction is going on, when we are touching it, you will feel heat. Okay, you may feel heat. That's why we are saying the heat is evolved. Okay, it is ejected out, it is emitted out. That is it. So quicklime, calcium oxide, again and again I am repeating because it is very important. Calcium oxide, quicklime, when mixed with water, we will get calcium hydroxide, slaked lime. Along with that, this heat is evolved. This calcium hydroxide is used in whitewashing purpose. Why it is used? You know, it will be in the rough form actually, but when after 3 or 4 days, what happens is, from the atmosphere, carbon dioxide is more, right? So it will react with carbon dioxide, and what happens? Calcium hydroxide reacts with carbon dioxide to form calcium carbonate, that is limestone. Calcium carbonate plus water. So calcium hydroxide, when it is in the aqueous form, when we are painting in the walls, what happens is after 3 to 4 days, it will start react with carbon dioxide, and it will be changed automatically to calcium carbonate, which makes a smooth finish for the walls. That's why it's very, very important. Okay. Here, what all things you have to learn? Quicklime, slaking lime, then limestone, that is calcium carbonate. It's also called chalk. Okay. So here we have noticed one thing, that is heat is evolved. What type of reaction it is? It is a combination reaction, but as the heat energy is evolved, it is called exothermic reaction. What is this exothermic? Exit. You know the meaning of exit? In the film halls, in cinema theaters, you will see exit. What is the meaning of exit? It is a way to go out, isn't it? This exit, exothermic. What is thermic? Thermic related to temperature. Temperature means heat. So the heat is exited, that is heat is emitted. That's why this kind of reaction is called exothermic reaction. Maximum combination reaction will be in the form of exothermic. Okay, dears? Second one, the important thing is in respiration, what happens? As we have learned in small classes, in the respiration we are intaking oxygen and it helps for breaking down to break down the food layer particles, and along with that we are getting energy, isn't it? What is the reaction? You know, this is the reaction. As we are intaking food, what is there in the food? The last thing itself, 2 seconds before itself I have written, no, carbon dioxide and water. In the presence of sunlight and chlorophyll we are getting carbohydrates. These carbohydrates are present in plants and we are eating this carbohydrate. So the carbohydrate we are intaking, this carbohydrate reacts with oxygen which we are respiring, which we are taking in. What will happen? It will be break down into carbon dioxide and water. Along with that, energy is also released. Along with the what happened? Energy is also released. This is also a kind of combination reaction. Okay? These two, what is a combination reaction? Name 2 examples. If such a question is coming, you can explain like these things about the calcium oxide as well as this respiration is also you can explain. Okay, dears? Now, decomposition of vegetable matter into compost is also a kind of combination reaction. Shall we go for the second? The second one is decomposition reaction. We have gone through the combination reaction. Now we are moving for the decomposition reaction. What is decomposition reaction? The reaction in which the reactants break down to form products are called decomposition reaction. Okay, dears? Here there are many examples. First one, ferrous sulfate. When it undergoes decomposition, we will get ferric oxide, sulfur dioxide and sulfur trioxide. This is the first example. Second one, we can see calcium carbonate. When it is heated, we will undergo reaction and we will get calcium oxide along with the carbon dioxide. Okay, dears? Then lead nitrate. Lead nitrate, when it is heated, we will get lead oxide plus nitrogen dioxide and along with that oxygen is evolved. Electrolysis of water is the best example for decomposition reaction. And the last one is about silver bromide or silver chloride also. When we are exposed to sunlight, we will get silver along with bromine. In case of silver chloride, silver along with that chlorine. Okay? These are very easy to learn, right? But the questions will not be as easy as you expect. Okay, dears? I will explain one by one. Ferrous sulfate. When it undergo heating, that means it is undergoing thermal decomposition. Temperature is involved in it. So we are saying this is thermal decomposition. What we will get? Ferric oxide along with that sulfur dioxide and trioxide. You can expect the question in this manner. A compound of iron, one is heated, which is light green in color. One is heated, we are getting white solid. White solid. Along with that, two gases are evolved. What is the reaction which they are undergoing? Okay, compound of iron. The compound of iron which is light green and is solid is ferrous sulfate. It is heated, means it is undergoing thermal decomposition. We are getting white solid. What is the white solid here? Ferric oxide. Along with that, two gases, what are they? Sulfur dioxide and trioxide. learn in this manner. You can expect question in any manner so that you can answer. Okay, you have to learn just an equation. If you are learning, it's of no use. If you are expecting question in the twisted manner, you have to prepare in that manner for getting answers. Okay. Then the second one, as we know, calcium carbonate is limestone. When it is undergoing thermal decomposition, we will get quicklime along with the carbon dioxide. Explain a way to get quicklime from calcium carbonate is the question. You can expect this kind of question also. How can we get quicklime from limestone? How? When limestone, when it is heated, it undergoes thermal decomposition and we are getting calcium oxide, that is quicklime, along with that carbon dioxide is evolved. Okay, you have to approach how the question it will be. Okay, yes. Then lead nitrate, when it is also undergoing thermal decomposition, we will get lead oxide, along with that nitrogen dioxide and oxygen are evolved. And the fourth one is electrolysis of water. We know how the water is formed when hydrogen and oxygen are combined. But when we are applying electricity to the water, it will undergo electrolysis, and in the test tube, one test tube we will get oxygen, and in the other test tube we will get hydrogen to a little extent. This is electrolysis. You have to learn it properly. 6 volt of electricity is passed, and one anode and one cathode will be there, and during electrolysis sulfuric acid is added along with water for this purpose, and how the electrolysis is happening and how we are getting oxygen and hydrogen we have to learn. Okay, yes. Then the important thing is silver bromide. So it can be asked in such a way that what will happen if we are keeping silver chloride in sunlight. When we are keeping silver chloride in sunlight or silver bromide in sunlight, it will undergo decomposition so that silver we will obtain and it will be grey in color. Along with that bromine gas here, the chlorine gas. Okay, is also evolved. These are the expected questions in that form of thermal decomposition. Now, let me ask you what all things are going in this decomposition reaction. In the decomposition reaction, all these kinds of reaction, either heat or sunlight is absorbed, or this heat or sunlight are involved in this reaction. They are also involved for the decomposition reaction. So these kind of reactions are called endothermic reaction. Enter. What? Temperature. Thermal means heat. When the heat energy is involved in this kind of reaction, we are saying these are endothermic reaction. Almost all decomposition reactions are endothermic in nature. Okay, dears? Let's see the third reaction. Now we are moving for the third type of reaction, that is displacement reaction. Take an iron nail and keep a test tube having copper sulfate solution. Immerse this iron nail in the copper sulfate solution. Wait for 20 minutes. Let's see what's happening. The iron nail, when we are taking it out after 20 minutes, will be brown in color, and the green color of copper sulfate solution has been faded to light blue color. What is the reaction happening here? This is the reaction. See, iron when react with copper sulfate will give you iron sulfate plus copper. This is the reaction happening. And what is the change is, iron nail when it is dipped in a copper sulfate solution, it was initially blue in color. When after this reaction, what happens? The iron displaces copper and keep in its position. Can you see? Copper sulfate has been changed to iron sulfate, for example. So this iron has displaced the copper, and in this position iron came and the copper is expelled, and this copper has been settled in the iron nail, the top of the iron nail as brown color. Did you get now? This kind of reaction is called displacement reaction. The reaction involves the displacement of a particular atom by some other atoms. This is called displacement reaction. Here see, zinc plus copper sulfate gives zinc sulfate plus copper. Again, lead plus copper sulfate gives lead plus copper chloride gives lead chloride plus copper. These are these kinds of displacement reaction. Now I am having a doubt here. Can this reaction be reversed? That is, iron sulfate plus copper when reacted, will we get iron and copper sulfate? No, we will not get. Why? Because this copper is not able to displace iron from its solution and to sit in its position because of the reactivity series. Reactivity series is the series which have the highly reactive elements in the top and least reactive elements in the bottom. So the highly reactive element will displaces the least reactive element and sit in its place like this. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, copper, tin, lead, then hydrogen, copper, then silver and gold. This is the reactivity series. Okay dears, it is very tough for you and me to learn it, right? So for making it easy, I am helping you dears. See, I have made this. See here, reactivity series. Can you see it properly? Can you see it properly? It is the potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold. Here, copper in copper sulfate solution is displaced by iron, which is in higher position than this in reactivity series, and iron sulfate solution is formed. Along with that, copper is gone out like that. So, how can you make it easy? With the help of mnemonics. See, Kanna. Pavitra starts calling Meena after coming zoo in time, leaving her costly silver gold at home. Is it not easy? Pavitra starts calling Meena coming zoo in time, leaving her costly silver gold at home. P. Potassium. S. Sodium. Ca. Calcium. M. Magnesium. A. Aluminium. C. Carbon. Z. Zinc. I. Iron. T. Tin. L. Lead. H. Hydrogen. C. Copper. S. Silver. G. Gold. Okay? I think it's very easy for you to learn. If you are knowing the reactivity series, you can say why iron is displacing copper and why copper is not able to displace iron in this kind of reactions. Okay, dears? This is a kind of displacement reaction. Here also zinc. Zinc is highly reactive compared to copper. That's why it was able to displace copper from the solution and zinc sulfate has been formed. Now is it clear? Lead, as the reactivity is more compared to copper, displaces it and keep its position with chloride. So, lead chloride. Okay, it's clear, I think. Now we are moving for the next thing, that is double displacement reaction. What is this double displacement reaction? In two areas displacement is happening. Okay, see, from the example itself you will come to know. Na2SO4 sodium sulfate plus BaCl2 barium chloride gives barium sulfate as well as sodium chloride. In this kind of reaction, here sodium has been displaced and barium also has been displaced. Sodium displaces and sit in the position of along with chlorine to form sodium chloride, and barium also get displaced and it is sitting along with sulfate. So barium sulfate solution is formed. Here in this reaction at the end what you are getting? You are getting a white colored precipitate over there. What is precipitate? In a reaction at the end, if we are getting a solid powdered product, it is called precipitate. This kind of reaction is called precipitation reaction. Precipitate, barium sulfate is the precipitate and it will be formed at the bottom of the test tube in the form of powder, white powder. Okay, this is called precipitation reaction. It's also happening in double displacement reaction. Second one, lead nitrate when reacted with potassium iodide, we are getting potassium nitrate along with lead iodide. Here lead iodide is a precipitate. It is a solid which is accumulated at the bottom. This kind of reaction in which exchange of ions are happening. Ions. What are ions? If the electrons are lost or gained, they are called ions. Here exchange of ions are happening. SO4 2 minus and Pa2 plus. When these will combine to form BaSO4. Okay, the exchange of ions are happening. This kind of reaction are called double displacement reaction. Next, we are going to see oxidation reduction reaction. Now, the last type of reaction which we are seeing is oxidation and reduction reaction. What is this oxidation and reduction reaction? We will learn in detail. Okay, we are taking copper. When the copper is exposed to air, after 5 or 6 days, we can see the black color coating over this copper. How it is formed? Actually, copper, when it is exposed, it reacts with oxygen to form copper oxide, which will be black in color, which is coating over this copper. How can we make over this? Means how can we get the copper back? What we have to do is copper oxide, when heated with hydrogen, what will happen? We will get copper, along with that water is evolved. Okay, dears? This kind of reaction is called oxidation and reduction reaction. How? It is a normal reaction. How can it be said as oxidation and reduction? See here, copper here reacts with oxygen. What is we will get? We will get copper oxide. Here oxygen is involved in this reaction and the substance gains oxygen. This copper gains oxygen and forming copper oxide, right? So this copper is now oxidized. What is it? It is oxidized. The substance which gain oxygen is called oxidized and this is called oxidation reaction. Okay, dears? Now this copper oxide, when heated with hydrogen, what happens? Copper is back along with that water. So what happens? This oxygen has been gone out from this copper and we are getting copper back, right? So the copper here, what it is undergoing? Reduction. Loss of oxygen is reduction and the gain of oxygen is oxidation. This is oxidation and reduction reaction. See, in this equation, zinc oxide reacts with carbon to form zinc and carbon monoxide. Here what is oxidation? Here what is oxidized and what is reduced? Here zinc oxide, it is already having oxygen in it. When it is reacted with carbon, zinc will be separated from oxygen. So what is it undergoing? Oxidation or reduction? Undergoes reduction because zinc is separated and the carbon is along with oxygen forming carbon monoxide. It is undergoing oxidation. Understood? Now we can say in other words, if the substance gain oxygen, it is oxidation, and with a substance which loses oxygen is reduction. It's clear now? In other words, we can see the substance which gains hydrogen is reduction and the substance which loses hydrogen is oxidation. Did you get now? The substance which gains hydrogen is reduction and the substance which loses hydrogen is oxidation. Manganese oxide, when reacts with hydrochloric acid, what happens? Manganese chloride as well as water and chlorine is evolved. These are the products. Here manganese oxide, it is having oxygen and it is losing this oxygen, so it is what? Reduced, while hydrogen which is not having hydrogen chloride which is not having oxygen with it is oxidized to form water. This kind of reaction having hydrogen either loss or gain. Basis on that also we can say oxidation and reduction reaction. Understood? Now we are moving for corrosion. What is corrosion? The substance or the metal especially when it is exposed to moisture, air, what happens after some time? The color of the metal will be changed. This is called corrosion. The corrosion can be happened in iron phase. or steel items, whatever it is, iron, we can see. Can you see the difference? This is the normal one. This undergo corrosion and the resultant will be in this form. It is having brown color. Why? Because 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 the oxidation reactions may be happening in the atmosphere from the atmosphere, and the color will be changed. It can also we can also say the silver, when silver anklets when we are wearing, after many days we can say the black coating on the silver, it's also a part of corrosion, and the green color over the copper, all these are the part of corrosion. Okay dears, then the last topic is rancidity. What is this rancidity? For all the food particles, food substances like what to say, oil or butter, milk, ghee, all these things, when we are exposed for a long time, the smell will be changed. Odor will be not pleasant. Odor means what? Smell. The smell will be unpleasant. Smell will be feeling for these things. Why? Because it is undergoing rancidity. What is that? Actually, these substances like oil, then butter, ghee, and all these pickle, all these items, when we are exposed, they will be oxidized from the air, and they will be corroded, and the smell will be unpleasant. So we will say it is not good food. We will not eat this kind of food. So how can we avoid this rancidity? We can avoid by adding preservatives or antioxidants, which helps for removing the acidity. Okay dears, this chapter is closed and we are moving for the sum up. What all things we have learned in this chapter? We have seen what is a chemical reaction, what all changes has been happened when a chemical reaction is occurring. Then we have gone for the chemical equation, balancing the chemical equation, and what all things we will learn from when we are reading this chemical equation. Then we have gone for the types of chemical reaction. What are they? Combination reaction, decomposition reaction, then a displacement reaction, double displacement reaction, oxidation and reduction reaction. And then we have gone for corrosion as well as we have gone for rancidity. Now, this is your question time. First question I have written on the board, KClO3, when it is heated in the presence of catalyst, will undergo reaction and forms KCl plus O2. What the question is, you have to say which kind of reaction it is. Which kind of reaction it is, and what is the specialty of this reaction. Okay, because it is heat over there, so you have to mention which kind of reaction and what all things are involved in this reaction. Okay. Second one, lead nitrate PbNO3 plus 2Ki potassium iodide gives lead iodide plus potassium nitrate. In this reaction, I have given this as in the aqueous solution, and this is also in aqueous solution. Lead iodide as well as KNO3 is there. I have written it here X and Y. You have to mention whether it is solid or liquid or aqueous solution or gas. All this you have to mention what is X and what is Y. Okay, is the question clear? Then we are moving for the third question. Here, titanium chloride reacts with magnesium to form titanium and magnesium chloride. In this reaction, the question is you have to balance this equation. Balance the equation. Okay, these three different kinds of questions I have asked you. We will discuss all these in the next section. Okay, thank you for watching. Bye.